Hello, this is Laura Wogzogen, your math instructor for this semester. We're now going to look at our MandM project. And so to access this, I'm going to go to Modules, and I'm going to find the project number 4, which is on MandMs. First thing I want to remind you guys about is that we have our StatDisk help for the projects, where we have an intro video, the manual, and also the helpful videos that were made by the author of our textbook. So down at the bottom, you'll notice we have project number 4, which is on MandMs. At the very beginning, you'll see this video, and then likewise, you will notice that there's going to be data and the project. So clicking on data, I uploaded this as a PDF file and then also as a Excel file too. So clicking on our PDF just to look at this, you'll notice I put my name first just to kind of use as a reference, but everyone's last names are listed here. And make sure you scroll all the way through to find your name. You'll notice that the totals are left blank, and that's going to be your responsibility to add up to see if you can get those totals for each color for our total amount of students in our course. So you'll notice for me, I have 19 blue M&Ms, 5 brown M&Ms, 5 green M&Ms, with a total of 58 M&Ms in my bag. So I assigned each and every one of you a bag of M&Ms, and so these are going to be the numbers that you're going to be working with for your project, along with the class totals, which again are at the very bottom, that last row that you're going to need to calculate. So from here, I'm going to go ahead and open up our project. I uploaded this also as a PDF and as a Word document. So there's an intro here with M&Ms. What's needed, again, a bag of M&Ms, which I did assign you a virtual bag of M&Ms. And then also StatDisk. So the directions say using the bag of M&Ms, we'll discuss the color distribution of the bag of M&Ms, hypothesis testing, confidence intervals, chi-square goodness of fit test, as well as reviewing other topics from the semester. The project is to be typed and completed in order. Show all work for any calculations such as outliers or z-scores. Upload your completed project as a single PDF file. So the color distribution of plain M&Ms as stated by the Mars Corporation is 24% of your bag should be blue, 13% should be brown, 16% should be green, 20% orange, 13% red, and 14% yellow. So again, you have your unique bag assigned to you. And activity 1 is asking you just to record the number of M&Ms by color in your bag, and then also for the class. So again, you would write down those numbers. Like, so again, for me, 19 blue M&Ms, I would put there 5 brown, 5 green, and so forth. Just copying those numbers down. This is a table. You are more than welcome to copy my table and fill it in from there, or create a new table. You can use StatDisk, Excel, you can use Google Sheets, whatever it is that you can to create a table. Activity 2 is now asking for us to complete the proportions. And so to do this, I'm going to take the number of blue M&Ms that I have in my bag and divide by the total M&Ms that I have. So I have 19 divided by 58. Brown would be 5 divided by 58. Green would be 5 divided by 58, and so forth. And again, I want you to note that it does say round your answers to 3 decimal places. Your bag is unique for you. The class proportions that you're going to calculate are going to be the same for everybody in our class. So you can always check with a classmate to make sure that you have the same thing. Activity 3 is worth 4 points, and these are talking about probabilities. This has been a while since we talked about probabilities in our class, and this is back from chapter 4, so it might be something that you need to go back and review. I do want to note that it does say to use the class data, so you're using those numbers for the entire class, and then it also tells you to round everything 4 decimal places. In addition, make sure you show credit for these so you can earn your points. Activity 4 is the easy one on the project, and it's just asking for you to list the programs that you're using, which for me would be StatDisk. For activities 5 through 11, you must include all output screenshots from StatDisk, Excel, or whatever computer program you're using. If no computer outputs provided, no credit will be given at all for that part. In addition, don't forget to state the null and alternative hypotheses, conduct the test, and state a clear conclusion for all hypothesis test problems. All p-values should be rounded 4 decimal places. All confidence intervals should be rounded 3 decimal places, and they also need to be interpreted. So starting off with activity 5, and again, activity 5 through 11, each of these are worth 5 points, and they all need to have a status output screenshot with them. So activity 5 says for the class data, find the 5-number summary, the sample mean, the sample standard deviation of the blue M&Ms, round 3 decimal places. And so for this, it does say for the class data. So again, using all of that data. And it does say to round your answers to 3 decimal places. Again, put your screenshot and then clearly state those answers right after or right before so we can find those rounded correctly. We did this back in the first project that we had, and using those descriptive statistics, we can find all these values. Activity 6 says use the mean and the standard deviation from activity 5 to determine what percent of bags of M&Ms have more blue M&Ms than your bag. Assume that this is normally distributed and round your answer to 3 decimal places. We have done this in a previous project also, and so using this, since it does tell us it's normally distributed, I am able to use that probability distribution and calculate this. So we'll take a look at that in a moment. Activity 7 says using the class data again, test the claim the true proportion of blue M&M candies is 0.24 at the 0.05 significance level. This is a hypothesis test problem, so don't forget to state your null, alternative, your p-value, conduct your test, which is comparing it to alpha and stating a clear conclusion. Activity 8 is creating a confidence interval, a 95% confidence interval for the proportion of blue M&M candies using the class data again, and it says interpret your results. For activity 9, this says use the data from the class to test whether the proportion of brown M&Ms is different than the proportion of red M&Ms at an alpha equals 0.05 level of significance. Assume independence. And so you'll notice that for activity 9, we do have 2 groups. We have brown M&Ms and red M&Ms. And for this, we're still doing a hypothesis test, so don't forget to state your null, alternative, p-value, conduct your test, and then also state your conclusion. Activity 10 says how many M&M candies should be sampled to obtain a 95% confidence interval of the proportion of blue candies with a 4% margin of error if the prior estimate of blue M&M candies is 0.24. So for this, for activity 10, we determined the sample size back in chapter 7, so it might need to go back and review those notes. And then activity 11 says the Mars company claims that its plain M&M candies are distributed with the following color percentages, and those percentages are listed there. Test the claim that the color distribution is as claimed by the Mars company using the data from your bag of M&Ms. Use 0.05 significance level. It also says in parentheses to include a table of both your observed counts. Those observed counts are the ones that I assigned to you that we looked at earlier for your bag of M&Ms, and the expected counts. We did a problem in our notes in chapter 11 very similarly to this that was using not plain M&Ms, so the percentages are different, but using peanut M&Ms. That's a great example to look at in your notes to help. So once you're done, you can go ahead and submit this as a single PDF. But next thing we need to look at is our stat disk. So I'm going to switch over to stat disk. And with stat disk, you'll notice that I can clear. You have a clear button up at the top that says clear. You also have an upload data. So there's 2 ways to get the data in. For some students, you're able to just copy and paste that data into stat disk from the file that's on Canvas. Otherwise, you can save it and then upload it. When you click upload, it says upload data to your sample editor, and you can choose your file. So from here, you can choose your file and upload it, and it will download all that data in that Excel spreadsheet onto stat disk for you to use. So looking at the different parts that we have on stat disk, we did a few things. Our probability determination, which is going to help with number 6. And again, using that normal distribution. We also have hypothesis testing, which we have a couple different problems. This is going to be number 7 and number 9, so determining which one to use from here. In addition, we have confidence intervals, which again, reading the problem and understanding, is it proportions or means, is it one sample or two samples? And then for number 10 was our sample size determining, and that is right above. And selecting that, you need to figure out if it's a proportion or a means problem or standard deviation, so read that carefully. And then the last one that we have is the goodness of fit test. That's number 11, which is coming from chapter 11. And so for this, you'll notice you have two things. You have equal expected proportions or unequal. So to determine which one to use, are the colors the same expected frequencies or are they unequal? So are those all the same percent? And if you remember, blue M&Ms was 24%, some of them are 13, some are 16, so those are definitely unequal expected frequencies. So from here you would select that and then choose where you have to input your data. So you will have to input your data with your expected counts along with your observed counts. So this is our project, our last project for this semester. Get an early start on it and definitely ask if you have any questions. Best of luck.